Hello guys, so we are going to continue the discussion with respect to deep learning. In our previous video, we have already seen about single layer perceptron model. We have seen that what are the disadvantages with respect to this and why we should actually focus on multi-layered perceptron model, which is nothing but ANN, artificial neural network. And this is where we are going to basically understand like how multi-layered perceptron model works. And in this video, we are going to focus on, or we want to get a very high level understanding of what is forward propagation, what is backward propagation. And this backward propagation has like this entire thing was invented by Geoffrey Hinton. He's an amazing scientist. He is basically called as a godfather of entire deep learning community. The deep learning work that he has specifically done. This is Geoffrey Hinton, an amazing personality. You should definitely read his research, whatever research that he has probably done. But the main research was based on this backward propagation techniques, and because of this, now we are able to actually create very deep neural networks also. And then we'll also get an understanding of basic understanding of loss functions, optimizers and activation functions, right? And as we go ahead, we'll be deep diving into each and every topics and we'll try to understand this. Okay, so let's go ahead and let's try to see this. And again guys, when I say multi-layered perceptron model, I'm basically talking about multi-layered neural networks. Okay, so let me write it down over here. Multi-layered neural network. Okay, multi-layered neural network. This is super important. Okay, now let me give you 1,000 feet overview about like how a multi-layered neural network works, because in a single perceptron model we just had a feed forward neural network, that's it, right? And then we had some threshold value. If some value is greater, whatever output that I'm getting from this activation or step function or whatever threshold function that we are using over here, if it is greater than the threshold value, we either have 1 or 0, right? And based on that, let's say if it is not matching, we again go ahead and update the weight, and we just have feed forward neural network. But we understood what is the problem with respect to that, right? So in this multi-layered perceptron model, what we focus on is we focus on something called as forward propagation and backward propagation. Because of these two steps, the efficient change of weights will actually happen, through which we will be able to get the model, we'll be able to train our model very much quickly. Okay, so let's go ahead and understand. Whenever I say multi-layered neural network, now let's take this as an example, and this is my data set, right? My data set has basically IQ and IQ of the students, study hours, like in a day how many hours a student is studying, and then how many hours a student is playing, and based on that I have a specific output saying that whether the student has passed or failed, right? Whenever we have one value, that basically means passed, otherwise it is 0. Okay, so here you can see that I am having 3 specific features, right? X1, X2, X3. Now these 3 features will get passed one by one to my input layer. So this is specifically my input layer. Now whenever I say single layered neural network, that basically means I just have one hidden layer, right? In multi-layered neural network, what may happen is that I may have more than one hidden layer, right? So in this particular case here, you can see that I actually have over here, so this is one of my hidden layer. So this is hidden layer 1. Okay, in this hidden layer 1, I have one neuron, but in real, we can have any number of neurons. We can also have any number of hidden layers in a multi-neural network. Okay, multi-layered neural network. And this particular layer is basically called as my output layer. Okay, so over here, you can see that I am specifically having 2 layers of neurons, right? One neuron is over here and one neuron is over here, and I'm saying this as an output layer since this is the last layer of this particular neural network. So in this particular case, I actually have a 2-layered neural network. Okay, we basically say it as 2-layered neural network. Like this, we can have any number of hidden layers. We can also have any number of hidden neurons. So this specifically is my neurons. Okay, neurons. Now let's understand whatever things we have discussed till now with respect to the previous example. Now the first thing, whenever I say forward propagation, this is super important to understand guys. Whenever I say forward propagation, that basically means we are performing some steps. Now along with this, I have already told you we will also add a bias weight. So let's say this is B1 with 1. And here also, since I have 2 neurons, here also bias will get added. So here also I will be having B2, and again the constant will be 1. Okay, we provide some kind of constant. It can be 1 or -1. B1 and B2 are also initialized randomly. Now, as we know, in the forward propagation, in the feed forward neural network, what all things will happen? We will first of all assign weights, W1, W2, W3, right? So these weights are initially assigned randomly. And I'll also be talking about what are the different techniques of initializing these weights as we go ahead. And here you can see B1 is also initialized over here randomly, and B2 is initialized over here. Now from here to here, after this hidden layer is basically connected to this output layer. So I'm just going to have another weight which will be like W4. Okay, so I hope you are able to understand this. Now the first thing is that the first step that I really want to talk about is about the forward propagation. Now, as you know, forward propagation basically means what? In this neuron, there are 2 steps that is going to happen. The first step is that, and again understand, whatever output I'm going to get from this neuron, let me write it as O1, and whatever output I'm going to get after from this particular neuron, I'm going to write it as O2. Now in the first step, what usually happens, we have already discussed, right? Over here, what will happen? It is summation of I is equal to 1 to n, x of I, w of I plus b, right? So that is bias. So in the first step over here, we are basically going to do the summation of x1, w1 plus x2, w2 plus x3, w3. Now I can definitely write, and this will be plus b1, right? I can definitely write this as summation of I is equal to 1 to n, w transpose x, right, plus b. Now this is what I'm basically using it, right? And this will be I and this will be I. So this is the first step that is basically happening. And after that, what we do? We apply an activation function on top of Z. So this is my step 1, very simple. And this is my step 2, right? We have discussed about this, right? So over here, let's say that we are also going to do this, and this particular technique, whenever we go and do this, we perform this operation, this is basically called as forward propagation. Okay, so this is basically called as forward propagation. So in forward propagation, we specifically apply the step 1 and step 2 in every hidden neurons. Okay, this is super important to understand, guys. Again, I'm repeating it. Whatever I'm actually doing with respect to this 2 calculation, it happens in every neuron, right? Now let me go ahead and let me show you what will happen over here. Okay, so let's consider that my W1, W2, W3 is initialized with some values. Okay, so here I'm just going to say my W1 is basically initialized to 0.01. Let's say randomly I'm initializing this. Okay, you can initialize any value. Okay, so this is my W1, this is my W2, this is my W3. Okay, now in the forward propagation, what will happen? First of all, I will go ahead and compute my Z. So over here, in the first case, I will pass my first record. What is my first record? The IQ is 95. So X1 will have 95. Study hour is 4. So X2 is going to have 4. And play hours is 4. I'm going to have X3 as 4. Okay. So what I'm going to do? I'm going to multiply 95 by W1. So here it will be 95 multiplied by 0.01 because the W1 is 0.01. Okay. And let's say the next one is nothing but 4. 4 multiplied by the weight 2, right? Because this both will get multiplied. So this weight 2 is nothing but 0.02. And W3, which is nothing but this 4, right? This is X3, right? X3 is nothing but 4. Then again, it will get multiplied by 4 multiplied by W3, which is nothing but 0.03. And then I'm going to add this bias. Let's say that the bias initialized over here in this particular case, I can consider it anything. So here let's consider that I'm going to initialize it to 0.001. Okay, so this is what is the bias that I'm considering. Again, it can be randomly initialized. We'll talk about all the initialization technique and which initialization technique we should definitely use. So this bias will get multiplied by 1. So it is 0.01. So this is what is my entire Z value. I'm just doing the summation of weights and the inputs, one summation of inputs and the weights plus bias. Okay. And this is the same thing that we have written over here. If you probably do the output calculation, I got somewhere around 1.151. Okay. So this is the output that I'm getting. And this is obviously the step 1 in any neuron, in any hidden neuron, right? In this hidden neuron, this is the first step that is going to happen. Now in the step 2, what is going to basically happen? We are going to pass through an activation function, and we are going to pass this particular z value. In this video, let's discuss about one simple activation function which is super important, which is called a sigmoid. Now what is the main aim of sigmoid is that sigmoid curve is basically created like this. Whatever z value we give, right, it is going to convert this z value between 0 to 1. Okay, so what it is going to do, it is basically going to convert this z value into 0 to 1. Right, I'll talk about this, why it is basically, why we specifically use this. Let's say this is 0.5. That basically means whenever I pass this z value to this function, and this function mathematically is denoted like this. Okay, so we basically write sigmoid is equal to 1 plus e to the power of minus z. So whatever z value that I'm getting over here, if I pass it over here, right, to this equation, I'm always going to get the value between 0 to 1. Now understand what is the importance of this. Let's say I'm keeping a hot object on my hand, right? Now when I keep my hot object on my hand, my weights will get triggered. And based on the activation function like 0 or 1, my neuron should get activated, right? My neurons should get activated, because saying that, okay, in this neuron, my hot object is placed, I have to remove this hand, right? So what is exactly happening over here? As soon as I keep my hot object, if this neuron is getting activated, that basically means through this sigmoid function, it is becoming 1. Okay. And it is saying that, okay, something is placed over here. I have to do some response to stimuli. I have to probably remove my hand. That is what exactly is happening. So this activation functions plays a very important role in activating the neuron and deactivating the neuron. Now, when I say deactivating the neuron, just understand this. If I place a hot object in my hand, I'm not removing my left hand. I'm removing my right hand. That basically means the neuron in the right hand has got activated and neuron on the left hand is deactivated, because it does not have any role. This is feeling the pain and this is sending the signal. And this is all possible because of the correct weights. Right now, we have just initialized the weights. We need to train this entire model in such a way that we should get the exact weights. Okay. So here you can see that in the step 2, what I did over here, and this is with respect to hidden layer 1. Okay. This is with respect to hidden layer 1. So in the hidden layer 1, I performed step 1 and step 2. After this, I passed my activation function. Let's say this is f of z. And here I'm just going to pass 1 plus e to the power of minus whatever value this is, 1.151. Okay. Now, once I get this value here, you will be able to see that I will be getting some value, and this value, if you probably do it with the help of calculator, you'll be getting somewhere around 0.759. Okay. That basically means the output of the hidden layer 1, that is O1. Here O1 is nothing but it is 0.759. Okay. 0.759 with respect to the hidden layer 1. Okay. Very simple, very easy to understand what has happened, and mathematically I've shown you. Okay. Now in the hidden layer 2, and we are still in the first record. Later on, we'll go to the second record when I will tell you. Okay. Now let's go to the hidden layer 2, because this O1 will now get passed to hidden layer 2, right? Hidden layer 2. That is what it is happening over here. See, this O1 will get passed to hidden layer 2, that is O2. Now in here also, we have initialized a weight W4 in this layer, and another bias B2 is getting added along with this. So in the next operation, what will happen? Let's say I'm again going to consider Z. O1 is going to get multiplied by W4, and then this will be plus B2. Now let's say that we have initialized W4 randomly. Again, let's say the initialization of W4 is 0.02. I've just initialized it randomly. You can initialize any value, because I really want to show you how things happen in forward propagation. Then let's say bias 2 is basically initialized to 0.03. You can add up any values, okay, as such. So what is O1 over here? O1 is nothing but 0.759 multiplied by 0.02 plus 0.03. Okay, so this becomes my Z value. So what is my Z value over here? My Z value is nothing but it is 0.04518. Okay. Now this is my step 1 again in hidden layer 2. In the step 2, what we do, we pass through the activation function. As I said, again, I'm going to pass this Z value to my activation function. Okay. I'm just giving this Z as a notation. And what is the activation function? It is nothing but 1 plus e to the power of minus whatever value I'm getting over here, 0.04518. So what will be the output over here? It will be nothing but 0.51129. Okay. So this is the output that I'm getting. That basically means here my O2 will basically have this output, right? So O2 is nothing but 0.51129. Perfect. So since I had two hidden layers, both these hidden layers are able to perform the operation, and now we are in the output layer with this particular value 0.51121. Okay. Now it is super important to understand. After we get the output, the most important thing that we get now is something called as loss function. Now what exactly is loss function? Loss function, what it does is that whatever output that I have got in O2, that is the predicted output of this particular model. Okay, that is the predicted output of this particular model. Now what is the predicted output for this particular model? Let's say I'm getting 0.51129. So over here, this O2 or this output, I will just denote this as y hat. Y hat is just like predicted. Okay. So my predicted output, I will just use like this brackets. So it is nothing but 0.51129. Okay. 29. Okay. So this is my predicted output. But I also need to find out what is my real output for this record. My real output is this much. That is 1. So what is 1 minus 0.51129? It will be approximately equal to 0.41. Now this loss function is basically talking about the error we got. Super important, right? The error we got over here. And the error is high because if I get my predicted output as 1, then only my actual output and my predicted output will match. But here it is not matching. So I'm getting a loss function of 0.49, which is my error. And my main aim whenever I'm training this model is to reduce this error. And right now I'm having a good amount of error, that is 0.49, right? Now based on this error, we need to minimize it. And how can we minimize it? The only way to minimize is to update this all weights, to update all these weights, right? So the updation process will be going from the back end process from here to here. First, we need to go ahead and update W4. Then we'll go and update W1, W2, W3. And this process is basically called as backward propagation. Very simple, right? I've made you understand what exactly is happening. And in the backward propagation, what we do, we try to update every weights. I'll talk about what is the weight updation formula in my next video, but this is just to give you 1,000 feet overview, right? So once the backward propagation happens and all the weights are updated, then what will happen? Then the next input will be sent. Once the next input will be sent, again in this hidden layer 1 and 2, all these steps will happen again. Again, we will go in the output layer. Again, the loss value will be calculated with respect to this output. And if the loss is not less, we'll try to reduce again the weights value. Again, this process of forward and backward propagation will happen unless and until we reduce our loss function. Okay, loss function. Now there is one very important thing. What is the difference? And this topic we will be learning. What is the difference between loss function versus cost function? Okay. And there are different loss function and cost function also. I'll discuss about it. Now just see that, guys, when I did y minus y hat whole square, I was doing this for every points. Understand this. I was doing it for every points, right? But now with respect to cost function, just imagine that this loss function, as soon as I was passing every single point, I was calculating y minus y hat. Okay, so this is super important. For every point, I was calculating y minus y hat whole square, right? The difference between the truth and the predicted. But with respect to cost function, here we calculate this error for I is equal to 1 to all the n points, y minus y hat whole square. That basically means we don't calculate the error in every point and update the weights. We just calculate the error at once and then we update the weight only at once, right? So if you are still getting confused, don't worry. What I will do is that I'll again repeat this. What is the difference between loss function and cost function? Not right now, but exactly I will try to show you when I'm discussing about the loss function, the different type of loss function. But from the overall 1000 feet height, I think you have got an idea about what is the difference between forward and backward propagation. And we have also learned about this one. If I talk about the backward propagation, how this loss function is getting reduced, how these weights are getting optimized, for this we use something called as optimizers. Okay, we use something called as optimizers. Now this optimizers is super important because it helps us to do backward propagation. It helps us to reduce this loss function, and then we update the specific weights, right? But I hope you got this idea about how a multi-layered neural network actually works. That was the main aim, to just make you understand what all happens in the forward and the backward propagation. In the next video, we'll deep dive into this backward propagation and we'll try to understand how things basically happen.